Oh, man! Dude! Ugh, gross. Anyway, time for some math. A logarithmic function is the inverse of an exponential function. Invented in 1614 by John Napier as a way to simplify mathematical computations, they have found a wide variety of applications in statistics and economics. You'll be seeing them a lot throughout your time at Ottawa U. Being the inverse of an exponential function, a logarithmic function is like its evil twin. Whatever the exponential function does, the logarithmic does too, but badly. Duh. An exponential function and its corresponding log function can be graphed by reflection across the y equals x line. Now that we've reviewed the basics, let's answer the most important question. What are you expected to know about logarithmic functions coming into Math 1300? There are two major things. Number one, you should be able to conduct basic arithmetic with log functions. The basic rules for log math are shown here. When separate log terms are added together, they can be smushed into a single log function by multiplying the terms. Note that the bases of both log terms must be the same. When separate log terms are subtracted, they can be combined into a single log function by dividing the terms. Again, note that the bases of both log terms must be the same. The exponent of a log term can be brought to the front. Ooh, that's a fun one. Let's get back to our list. Number two, you should be able to solve logarithmic equations. When a prof asks you to solve an equation, they're asking you to isolate for the unknown variable, which is usually x. Let's try an example. Consider the expression 3 ln 3 plus ln x equals ln 4. Pause here if you would like to try the question yourself. We need to isolate for x, which is in the second term on the left. Moving 3 ln 3 to the other side, and simplifying the right side using logarithmetic, we end up with the expression ln x equals ln 4 over 27. The x is stuck inside of the ln function, which is the same thing as saying log base e. Basically, this log function has locked away x. To unlock x, we need to use the key, which is an exponential function with the same base. In this case, this is the exponential function with base e. Applying the exponential function e to both sides, we can now solve for x. Doing this is called exponentiation. Therefore, x equals 4 divided by 27. It is best to leave your final answer as a fraction, unless your professor says that you can round your answer. Let's try another example. Consider the expression log x minus 4 plus log x equals 2 log 4. Pause here if you would like to try the question yourself. Again, we want to isolate for x. X appears in two places. First, we can combine the two terms on the left using logarithmetic. The term on the right can also be simplified. Now, the x is stuck inside of the log function. When written this way, this is a log function with base 10. To unlock x, we need to use the key, which is an exponential function with the same base. In this case, this is the exponential function with base 10. Applying the exponential function 10 to both sides, we can now solve for x. Doing this is called exponentiation. We are left with a quadratic equation. This equation is not easily factorable. Instead, it is best to solve it using the quadratic formula. Note that the plus-minus operator tells us that we will need to do two separate calculations. In the first calculation, you will add the two terms in the numerator. In the second separate calculation, you will subtract the two terms in the numerator. We have a equals 1, b equals negative 4, and c equals negative 16. Plugging in our values and simplifying as much as possible, we get x equals 2 minus 2 root 5 and x equals 2 plus 2 root 5. It is best to leave your answer written like this and not in decimal form unless your professor says you can round your final answer. I know, it's a lot. Hey, it's Katrina from Prep 101. I really hope you enjoyed that primer. There's definitely more where that came from. Make sure to join the Facebook Study Hub for this course where you and your peers can communicate, ask questions about the course, and get access to free study aids. Use the link in the description box. I hope to see you at our prep sessions. I'll break down the course content for you step by step, show you how to solve actual exam questions, and maybe we'll get in a few laughs along the way. Many prep sessions for midterms are free. Yeah, free. Visit prep101.com for details. Thanks for watching. See you soon.